very much. Is this on? It is? Oh, excellent, fantastic. So welcome to our talk on the future of machine learning and JavaScript. And thank you very much for that intro. So my name is Asim Hussain. You can find me on Twitter as Jawake, not Joashe, but Jawake. I have a new website, asim.dev, which I launched yesterday, and I just changed the DNS records at like midnight, so it might be working, might not, I don't know. And I'm also a cloud developer advocate at Microsoft, so I work with the Azure platform. Actually, now I lead advocacy for EMEA. And yes, this is us. This is Cloud Developer Advocates. So we are the open source advocates on the Azure platform. If you go to that link at the bottom, you'll find all of this is an old videos. There might be some changes there. And you can, whatever your technological interest group, you can always find somebody in our group to chat to online. I'm an instructor on Udemy. Anybody know Udemy here? Anybody my students on Udemy? Come on, just one. Okay, so like a year or two ago, they added in automatic subtitling to the course, and my name is Awesome, which is also how you can pronounce my name. There you go. So hopefully this talk is going to be awesome. I should retire this joke. It's so funny. I'm going to do just a little bit of a bait and switch for a little bit, because I'm going to talk about the future of JavaScript and machine learning. But I'm also going to spend a few minutes right now to talk about something else I'm really passionate about, and that's climate change. Just like 5 minutes of your time. I use the word climate emergency because it is an emergency. I'm going to just do a quick quiz to the audience. Everybody loves my quizzes. So, there's been 5 mass extinctions on the Earth. 5. Where over half the species died out. First one was, when was it? 445 million years ago. 60 to 70% of all species and animals died. What caused it? Any guesses? Climate change. There you go, a bunch of volcanoes. Okay, another one happened 375 million years ago. 75% of all animals died. What caused it? I heard climate change. I'm going to take that one. All right. The other one, it's called a big death. We almost all died on this one. Well, all life. 95% of all life on the planet died. What caused it? Shout it out. Wrong. It was an asteroid. Right? So this is the asteroid one. This is the one that we hear about, like an asteroid killed all life. But then soon afterwards, 200 million years ago, happened again, 70 to 80%. What was it? What was it? Climate change. There you go. And this is the one, the last one. This is the actual one, what we call dinosaurs. It was only 66 million years ago, the Cretaceous period. What caused that? It's controversy. There's controversy. We all hear about that one as the asteroid killed it, but there's actually the other one, there's actually real evidence of the asteroid impact crater. The most recent one, there's not really clear evidence. One of the prevailing theories right now is that it was climate change, which they could have survived, but an asteroid came along, took it over the edge, and they all died. And now a lot of people talk about the current one, man-made one, right? 97% of scientists agree that climate change is happening and that it's man-made. 97%. 97%. When have 97% of people ever agreed on anything? 97%. And I saw this statistic and I immediately thought, who are the 3%? Who are they? What are they saying? And I did some research, and I basically found this website, which had done some additional analysis. So that original study, which talks about 97%, what it had done is it had taken 2,000 peer-reviewed papers and analyzed them. So this person, it's a site called Skeptical Science there. So what it done is it had then done some data science on it, so further bucketed those papers by expertise in climate change, and then whether or not the paper concluded that climate change was happening, that's man-made. And what it concluded was this: the more of an expert you are in climate science, I.e. a climate scientist, the more likely you are of believing that it's happening and that it's man-made, the less of an expert you are in climate science, right? The less likely you are to believe that it's happening, that it's man-made. The dumber you are, the less likely you are to believe it's happening. There's another frightening number that gets thrown around. So about 2016, there was a Paris Agreement where 196 states kind of agreed to sign on to trying to do some measures which kept the temperature increase that's going to happen to less than 2 degrees centigrade. Ideally 1.5, but less than 2 degrees for the next 100 years. And I was thinking, 2 degrees? What's 2 degrees? I couldn't tell if there was a 2-degree change. What's the point in 2 degrees, right? And what it is this, is basically, there's been lots of studies. We're talking about the average temperature over a long period of time, right? There's lots of studies done. This is a really great website called Carbon Brief. It has many, many more conclusions and slides like this. It's basically taken lots of papers and research into this and presented in a very easy-to-consume way. And it's got lots of different slides. This is one of the ones that I find most frightening. So at a 1.5-degree increase, this is the proportion of species losing 50% of their climatic range. When we get hot and cold, we just take off clothes and put on clothes. Animals and plants can't do that, right? They die, right? So 1.5 degrees, single digits, right? Invertebrates, plants, fucking insects, whatever. 1%, right? We can survive. 2 degrees, we're getting into double digits, right? 4.5 degrees, we're fucked. Look at that, right? That's why the small temperature degree, that's why it's really important. It's not a small number and it's okay, we can somehow achieve it. It's really, really important. This is the World Bank, right? Whatever your feelings of them, this is what their statement is about a 4-degree centigrade world. There is no certainty that adaptation to 4-degree change is survivable, right? It's possible. Right? 4 degrees is a big thing. It's not a little thing, it's a big thing. We might not be able to survive a 4-degree centigrade change. And the thing is, we're nowhere close to even remotely achieving our 2 degrees. We're much, much more likely right now with the changes that are in effect to get to 4 degrees, right? Or more. And I know some of you are thinking, Asim, you liberal lefty, right? You're quoting all these left-wing websites that say all these things. How about this? Raytheon, they're an American military contractor. They make missiles and lots of other defense-based stuff. And I think the military contractor, they're pretty honest about what they do. They're like, hey, you can buy this thing. It doesn't kill that many people, but it's pretty cheap. Or you can buy this thing. It kills a lot of people, but it's pretty expensive. Like the military contractor, they're pretty honest about this stuff, right? And they predicted, they quite honestly say that they expect to see demand for its military products may increase due to climate change. Right? So companies are going to plan to make money on it. Right? What can you do? Now, there's some things you can do right now. Right now, what's happening is the reason I'm talking about this right now to this audience is on the 20th of September, coming up to less than a month away, there's a global climate strike happening. So lots of people all over the world, it's youth-led, lots of people all over the world are just going to walk out of work. It's going to walk out of work, right? Some of the things you can do if you don't want to take part in that is you can do a digital climate strike. That's what I'm doing. So it's just, if you go to digital.globalclimatestrike.net, it'll give you a script tag. You can just add that to your website, and then this appears. Right now, this appears on the bottom of my website. On the 20th of September, my website will be blacked out, be greened out, okay? You can have a version of it if you want, which can be cancelable, but it's a good way to show support for this movement. And yeah, you can just go to digital.globalclimatestrike.com and you can add that to your website. Yeah? Go on. Yeah? The dying of tweets. Trees. Oh, is this a Switzerland thing? Oh. Ah. Okay. Okay.
One other question. What is air made of? Air. What does it consist of?
Oxygen, nitrogen.
How much?
I can't remember the specific numbers.
About 22%
Yeah.
oxygen.
Yeah.
About 70% nitrogen. How much CO2?
I can't remember.
0.034%.
Yeah.
0.034%.
Yeah. What's your point?
My point is, we have a lot of atomic tests, thousands.
Yeah.
They release a huge amount of energy and destructive energy. Much more likely that they cause climate change, but not CO2.
One of the 3% there. Nice to meet you. If the other thing you want to do is, if you want to do something a bit more and you want to connect with other people to join forces and do something with your power that you have in the technology space, is you can join a community called climateaction.tech. It's actually a Slack group, so you can go there, you can join, and you'll find other people, and they help you to not just find other people, but they have something called an accelerator where they will help you to talk to your board and your company to perhaps bring on board measures which help your company to reduce its carbon impact. Okay? All right, back to our regularly scheduled programming, the future of machine learning and JavaScript. Right, so I co-organize a meetup group in London called AI JavaScript London with my friend Eleanor Haproff. We started it kind of start of last year, kind of a bit of a psychological break here right now, isn't it? It's kind of climate change and now this. Okay, it's all going to be fun and games from now on, trust me, right? So start of last year, I remember, yes. We started a meetup group in London, and it became very popular. We're now kind of over almost 2,000 people, and we're running these meetup groups talking about AI and machine learning and JavaScript. And what would happen is people would come up to us at the end of the meetup and then say, Asim, do you know about this app? It's built in JavaScript. It demonstrates the things you're talking about. We're like, well, okay, that's awesome, that's amazing. We'd add it to a list. And so eventually what we did is we created a website called AI-JS Rocks. And if you go to that website, you can actually find a whole bunch of JavaScript applications that use machine learning or teach you some aspect of AI. And the reason it's really interesting because it's written in JavaScript, so you can go, you can see it working in the browser, you can view source to see how it was built. It's all got links to GitHub, so you can actually really figure out how these things are built. And I personally found this a really good way of learning about this space, because you see something, you're inspired by it, then you can go and figure out how it was built. And so that's what we're going to talk about today. Is we're going to talk about 3 applications that are on AI.js Rocks. I'm going to talk about how they were built. And through that process, I'm going to teach you a little bit what's happening in this space, some of the things you can do, and where to learn more. All right? Awesome. So the first one, the Mojifier. Okay? It's not trademarked. It's just the Mojifier. Thought it would be fun. And I made this one. It does something incredible. Truly wondrous. Okay, if you give an image that contains a face, it will detect the face. It will detect the emotion in the face. And it will then, any guesses? It will replace the face with the appropriate emoji, basically, yeah, and then paste that back out. There you go. Pretty amazing stuff. Wonderful, the Emojifier. You can actually go, if you go to themojifier.com, I've created it as a Slack bot. So you can actually go right now, click add to Slack, it will add it to your Slack workspace, and you can have lots of fun with it. Useful business conversations with it. This is how it works. This is my son. There you go. And you type /Mojify, an image, boom. There you go. That's his emotion at that moment in time. It works for multiple people in an image. There you go. And it has answered an age-old question that has been plaguing artists for years, and there you go. That's Mona Lisa smile. All right, so pretty revolutionary stuff. It does quite a lot of different things. One of the things that it does is, one of the things I think is interesting that it does is, how the hell does it calculate emotion? I can barely see what emotion people are, right? How can we teach a computer to detect emotion? Right? It's pretty simple, it turns out. There's only 2 steps. First step, you've got to detect the facial features. Okay, so now we know that faces, at least most faces, have a very clear set of facial features most faces have, right? And there's lots of different algorithms you can use to get those facial features. You can go to that link there. I'm not even going to list them. There's loads of different ways of getting those facial features. But there's some well-known facial features, right? That's the first step to detecting their emotion. If you can imagine the lips, if they were this way, you're probably happy. If they're that way, you're probably sad, right? So you can imagine how this is feeding into it somehow. And the second stage is really, really simple. You just use a neural network. So just those 2 steps, and then that's it. That's all we need to do to make, just need to explain neural networks. Okay, fine, I'll go there. Okay, so what is a neural network? So a neural network has a basis in biology. Each of us have like neurons in our head, at least one of them. This is one neuron. Has some dendrites going in, a body, and an axon going out. If enough electricity flows into the dendrites, the body activates and pumps electricity out through the axons. That's it. That's it, right? You stick enough of these together, you get a brain. Personally, I think consciousness comes from somewhere else, but that's what gives you a brain. If I was to ask you to code this up in JavaScript, you'd probably try and furiously remember, 101 graph theory or something like that. I can't remember. We have like a node, edges, all right? 2 edges going in, a node and an edge going out. You have the features, like the facial features, some features that you want to deduce something from coming in. Maybe it's, I forgot what example I used here. Maybe this is day of the year, 23rd day of the year, and the temperature. And then each edge, you basically give it a random number, because you're initializing it, a random number. And then you multiply them both together, add them up, and you pass it through an activation function, wherever the hell that is. And wherever it pumps out, that it pumps out. So that's kind of like electricity flowing in, a body, and electricity flowing out, right? The activation function might just look something like this. So maybe you take your inputs, you multiply by some weights, you sum them together, you pass it into an activation function, and it's just a function. Whatever that function pumps out, you pump that out. That's all that's really happening here right now, right? There's lots of different types of activation functions. This is a very simple one. Anything below 0 is 0, anything above 0 is 1. So 7.1 would result in 1. And that's it. You basically put enough of these together, you get a neural network. This is what's called densely connected feed-forward neural network, which is 4 layers. 1 input layer, 1 output layer, 2 hidden layers, right? Just a bunch of nodes, some edges, some weights, just multiplying some stuff together. And then you get a data set. In this kind of model, you get a data set. And to detect emotion, there's actually some very well-known data sets, free data sets, academic data sets you can get, where people have already taken lots of images of people's faces, and next to it said, this is happy, this is sad, this is confused, whatever. I don't think that's... Is confused an emotion? I don't think it is. I think it's a state. And that's what you do. So basically, you'd create that, you'd create the neural network, you then would initialize all those edges with random numbers. You'd get your data set, you'd go through it one at a time, you'd pump in some values, maybe the inputs are those facial feature positions, the positions of the eyes, the nose, the lips, something like that. It multiplies all the way through, and it pumps out a number. 3. What does 3 mean? Well, we decided, I decided that actually it's 0 is unhappy and 10 is happy. And each of these input images, maybe they're labeled 0 to 10. So maybe they said this is 8 happiness. So this neural network has it wrong. This neural network was given an 8 happy image, and they said it's 3 happy, so it's wrong. Of course it's wrong. We initialized a bunch of things with random variables. You're not going to get a neural network. You're not going to get something intelligent that way. The secret is in knowing how wrong it is and then doing something called a backpropagation algorithm, which then tweaks those weights, tweaks them a little bit, so that then next time when you pass that data, it gets closer to 8. This is what we call training. This is all it's doing. It's basically figuring out how wrong something is and then slowly tweaking these weights again, until it gets better. Right? I think I've got some animations here, which I forgot about. And then yes, and it just tweaks them until the next time it comes through, it gives you 8. Okay? Scan that. Went too fast, past there. But anyway, that's what a neural network does, right? That's what happens when you train it. You could have done that. I could have done that. I could have done that for Mojify, but I didn't. This is a very, very common problem, and this is one of the things you'll find is now we're in 2019, almost 2020. A lot of these common problems are now being commoditized into APIs that a lot of different companies are providing. So on Microsoft, we've got something called the Face API. Everybody's got APIs like this. And Microsoft one got one called the Face API, where you can pass in an image that contains some faces, and it gives you a whole bunch of information back about it. Behind the scenes, it's using a neural network, which is kind of trained the way I said it was trained. I actually don't know how it was trained because it's proprietary knowledge, but it's kind of trained the way I just described it. And to use it, you just basically pass a path to an image, to a URL as a post, and it gives you a whole bunch of data back. This is only a subset of the data it gives you. This is a subset of the data. So for each face in the image, it gives an array with the rectangle of the face, because remember, we're placing emojis. We need to know where the face is. And also emotion attributes. So from 0 to 1, it gives you values for anger, contempt, disgust, fear, happiness, neutral, sadness, and surprise. Who's got a beard? Hand up. I see a beard there. There we go. Some beardies. You cannot be 100% happy. Right? I've tried. I can only ever get to 99% happiness. So, sadness. And that's basically what I did. That's how I built the Mojify, was I used the Face API, grabbed the emotion from the face, figured out a very, very clever way of matching that to an emoji, and then pasting that back to the user. Mojify. Now we know a little bit about neural networks. So just to summarize, neural networks are incredibly powerful. Okay? We talk about all this stuff that's happening in machine learning in the last 10 years. A lot of it's been driven by neural networks, just these algorithmic ways that we've got to build machine learning algorithms. But conceptually, they're quite easy to understand. I mean, I kind of broadly told you the broad outlines of it in kind of like 10 minutes, right? Conceptually, they're quite easy to understand. Obviously, it gets much, much more complicated the further, more in depth that you go. There you go. All right, second one. Second demo. TensorFlow, MobileNet, and I'm fine. Here we go. Here's a video. So I run a workshop in London where I teach machine learning with TensorFlow. And after the workshop, one of the gentlemen, Oliver Turner, built one of these and sent it back to me. I love it when I do workshops and students build something based on what I taught them and then send it back to me. Such a great feeling. We sent this back to me, and it's just a simple code pen. Oh, you can find the link at the top there. And what it does, basically, it does at the bottom, when it does it's doing a query to Unsplash for an image. So it's doing Unsplash for puppies. And then it's trying to figure out what's inside the image. You can see at the bottom here, 78% t-shirt. It's not doing the best job in the world. Here it's got terrier. Here it's 10% terrier. Now the important thing is that the only API request that's happening here is to Unsplash for the image. Everything else is detecting what's in the image is happening in the browser in JavaScript. Now that's using a technology called TensorFlow. Who here has heard of TensorFlow? Who here has used TensorFlow? Oh, okay. Fairly respectable number of the audience. Okay, excellent. So TensorFlow is a technology. It was open sourced by Google in 2015. And it allows you to run kind of mathematical computations across quite a few different nodes, quite a few different GPUs, really parallelize a lot of them. It's pretty hardcore. It's written in C. You have to install it. It does take, it is optimized to do a lot of compute. But last year and a half ago, some time ago, they released TensorFlow.js. Yeah, we love it, don't we? When you add a JS on the end of things, we're like, yes, we can do something now. So TensorFlow.js. Now, when I first heard about TensorFlow.js, I first thought, this is just, you have to install TensorFlow, it's going to be some node bindings, you have to it's going to be ugly. No, TensorFlow.js is TensorFlow completely rewritten in JavaScript, right? And that's awesome. That's awesome because then, in order to do machine learning with TensorFlow, this is all you need. That's it, no other dependency. Either an import statement if you're a proper developer, or if you're like me, you put a script tag at the bottom of your page and hope no one notices. That's all you need to do. Now you can do everything, you can do a lot of stuff with TensorFlow. You can do pretty much everything you do with main TensorFlow. You can train models. So the thing I showed you with Modifier, where you train a model, you get the node, you put the weights, you train it, you tune it, you do the backpropagation. You can do that with TensorFlow.js. You can do that with TensorFlow.js. You can also load pre-trained models. Models that people have already created, trained, and saved as a JSON file and put somewhere on the internet. You can load them. And if you go to the TensorFlow.js website, you can actually find a whole bunch of pre-trained models that you can leverage. And that's what Oliver used. He used one called MobileNet. And this is it. You load MobileNet, you get the image, you load MobileNet, and then you basically call model.classify with the image, and it gives you those percentages. That was it. 4 lines of code. 5 lines of code. Just to do that amazing functionality in the browser right now. Pretty incredible where we are, really, if you think about it, compared to like 10 years ago. And that's what Oliver used. However, MobileNet, the clue's in the name. Mobile. It's optimized for mobile. These models can be very, very, very large. MobileNet only can detect 1,000 things in the entire universe. And so that's why it wasn't very good, right? If you really want to detect what's inside an image, you need to train a much, much larger model, things that probably aren't going to be suitable for mobile devices, things you need to use an API for. And again, a lot of companies have commoditized this. I work at Microsoft. We've got the computer vision API, which we can pass it an image and it tells you a whole bunch of information about it. Okay, scarily, not scary, I shouldn't use that word with machine learning talk. Let's cut that one from the video. We get a whole bunch of things with it. So one of the things that it does do that I think is quite really fascinating, that is a better word, is it can give you a human readable description of an image, a caption of an image, right? So my friend Sarah, she made this code pen ages ago. Thought, this would be great for accessibility. Like if you forget to put the alt tag in an image, what if you can somehow get the textual description, put that in the alt tag? She wrote this as a demo. So again, it's a code pen. So you can go, and this is it working. So does anyone watch *Halt and Catch Fire*? 2 hands. Come on, this is one of my favorite TV shows. It's about the advent of kind of computing in 1985 to like 1995 or something. I can't remember. It's a fascinating look into the history of our world. And this is the description it came up with. Mackenzie Davies et al. Standing in front of a building. Mackenzie Davies is the actress in the middle of the screen, and that's what the API returned for an image. Pretty cool, right? Pretty cool. However, she posted this on Twitter, and as we all know, Twitter's full of really friendly people who like to just, obviously help you out by telling you when you're wrong. Okay, and some people obviously helped her out and told her that it was wrong sometimes. So here's one. These were not cruel tweets in any way. They're quite funny, actually. So here's one that says, well, this one says a star-filled sky. Text says 4. So we didn't really... Got a star-filled sky, right? But there's no text there. The next one could be true. Could be true. I mean, you don't know, for sure. Those could be dead, stuffed cats on a bed. The next one's pretty good. I like the next one because it's 50% right. And 50% in my books is a pass grade. My dog posing for a camera. Okay. All right. So not perfect, right? But pretty good. Pretty good. I think 10 years ago, we couldn't tell the difference in an image if an image was a cat or a dog. Right? Now this is where we're at. Pretty exciting. Just to summarize, this is one takeaway you take from this talk. It's just that TensorFlow.js doesn't have any dependencies. If you really just want to start playing around with machine learning and not really getting too involved with stuff, it's just a really great place to start. And also, if you want to use machine learning in your websites and JavaScript applications, it's obviously a great place to start. And MobileNet is a really great place to analyze them, tool to analyze images. When I teach this stuff, I always start off with MobileNet because it's kind of fun. It's a great way to dip your toes into it. I do recommend, if you are going to start, and start with a pre-trained model. If you do want to do something really in-depth with images, be prepared to either put a lot of effort into figuring out certain algorithms and money into training models, or use a pre-trained service like what we have. All right. I think I've got time for the final one. My favorite. Image to image. Okay, let's watch it. This is it. If you go to AI-JS Rock's website, you can find image to image, and you can click it, and this is it. This is image to image running in the browser. Okay, so what is it doing? If you draw the outline of a cat, it will fill in the rest of the cat. Amazing, yeah? Revolutionary. It is actually pretty incredible, to be honest with you. It's created by a guy called Zaid. Oh my God, I'm going to pronounce his name incorrectly. He's still a student in Saudi Arabia. And I wasn't doing this stuff when I was a student. I was doing different stuff when I was a student. But anyway, great things ahead for this guy. How does it work? It uses a technique called a GAN, a generalized adversarial neural network. Generative adversarial neural network. And what that is basically two neural networks competing together. And that's how I went through this in this way, because now you know what these are. Now you know what these are. These are neural networks. There's two of them competing with each other. There's one called a generator, and there's another one called a discriminator. So the generator's job is to generate cat images. The discriminator's job is to detect whether a cat image is a fake one that was generated or a real one. That's the discriminator's job. And what you do with a generator, remember a generator was initialized with random numbers, right? You give it some input. Input could actually be anything, but we're giving it an input of an outline of a cat. So there's lots of images in a directory. Each image is the outline of a cat, different outline of a cat. You feed that in to the inputs, okay? And it generates a cat image. But it's not going to do a very good job because they're initialized with random numbers, right? It's going to probably generate noise. But whatever, we take all of those images and we combine them with real cat images and we feed all of those into the discriminator. And the discriminator's job is to detect whether it's a real cat image or a fake cat image. But remember, the discriminator was initialized with random numbers. So it's not going to do a very good job. It's probably going to say that's a fake cat image and that's a real cat image, right? The secret is in then we can numerically figure out how wrong it is, and we do that back propagation, so we tweak it, so next time around it does it a little bit better. But what if the discriminator got it right? Well, then that means the generator isn't doing a good job. So then numerically figure that out and you tweak that. Okay, I skipped past too fast. But anyway, you tweak the generator. And that's what's happening is the generator gets better at generating cat images, then the discriminator gets better at discriminating, and they fight with each other, 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 until eventually the discriminator really can't tell anymore whether it's a real cat image or a fake cat image. And you're like, oh, it's done, right? Then we throw away the discriminator. We don't care about the discriminator anymore. All we care about is a generator. And we take that, we export that to some JSON format, which you can then load with TensorFlow.js in the browser, and that's how Zaid got the cat image generator. All right, that's how it works. And why they're interesting is the word generative. They generate things. Lots of other kind of useful aspects of machine learning are discriminatory. Like they can detect if one thing is one thing or another thing. They're not creative. They're not artistic in a way. The generators are interesting because they generate, they create. Okay? But all right, it generates cat images. Who cares? So what? I mean, it's not as impressive as my Mojifier, but who cares, right? Well, it doesn't just have to work with cats. It can work with anything. Right? So the images on the left are the input images, the outlines, and the images on the right are the output images. So those things that look like real images are not real images, they're generated. Okay? But this isn't, that other thing was using an algorithm called pix to pix. This isn't pix to pix. This is vid to vid. Right? This isn't working in the browser yet. Everybody's silent again. Silent at the start and silent at the end. That's the way I like my talks. There's one or two jokes in the middle. Okay, and you can also have multiple outputs. More silence. What have we built? And the input doesn't have to be just outlines. The input can be anything you want it to be. Anything you want it to be, right? The input here is a segmented image, so the color gives you some hint of depth or some other information about the image, right? Then you can do more interesting things like this. Okay, so she's not dancing. Right, somebody else has danced or... And in fact, if you look closely, you can see that they're kind of more like stubs of hands moving. So there's some way of detecting still. Have we got another one? Yes, so here's another one. So this is a car scene. I don't know how does it look like for you? So the bottom right-hand corner is the vid-to-vid algorithm, and the input is the top left-hand corner. The other two ones are just different algorithms. So the bottom left-hand corner is generated, right? It's generated using a GAN. And the input doesn't even have to be an image. The input can be anything you want it to be. The input could be text. It could be text. So here is some text. So that's the input, is that text in the top thing. This flower has long, thin yellow petals and a lot of yellow anthers in the center. Stage 1 is 600 iterations. Stage 2 is 1,200 iterations. Oh, that one's not so good, but whatever. So he generated it from that. And there's another one for the birds. Oh, hang on. Yeah, bird. This bird is white, black, and brown in color with a brown beak. So you can see, pretty good. There's one that's not very good. This one. Oh, and this one. The rest of them are pretty good, right? That's generated images, just from text, okay? How far away do you think we are from somebody typing in, I want an e-commerce website, here's my logo, 4 pages, I'll be selling cars, yeah, go. It's generative. They generate things from inputs, right? I was giving this talk once at a conference, I won't tell you where it was, and the CTO of a large firm jumped out the back, goes, "We're looking at that!" Anyway. I like to scare the shit out of my audience. This is it. So GANs. The GANs learn to generate new images. They're generative. That's what's so interesting about them. They take a lot of compute to train, but the eventual model that you can create can be optimized to run in the browser. The cat one was, I think it got it down to 13 megabytes in the end, right? Still pretty big, but reasonable. Oh, if you want to learn a bit more about machine learning, I am launching a book. I was going to launch it yesterday, but then something hadn't happened, right? So you can go to land.asim.dev.tfjs, and I'll be launching a Kickstarter from the next few days, see if anybody's interested in that book and videos. And yeah, if you want to learn a little bit more, if you want to especially learn how to build something like the Emojifier, you can go to that link there. I've got a full tutorial, step-by-step, which takes you through everything for building a Slack bot with all that wonderful AI capabilities, if you want. And that's it, I think. Yeah, that's it. Thank you very much for your time.